Okay, right. Welcome to iteration. Question 1 says, show that the equation t cubed plus 4t minus 2 equals 0 has a root alpha between 0 and 1. Okay, so this is going back to, if we think back to GCSE when you did trial and improvement, okay, and you would try and find a solution to this. So in other words, a value for t. Okay, you find a value for t that satisfies this, that makes it equal to 0. Now often you can't find a value, okay, because the value is an irrational number that goes on forever and ever. So you can't actually find the value, but you can find it to a certain amount of decimal places. Alright? But here they're saying that this root lies between 0 and 1. Okay, so they called it root alpha. Okay, so when they say root alpha, what they're talking about is the value of t that makes this 0. Okay, so there's a certain value t that makes this 0, and they called it root alpha. And they want you to show that it lies between 0 and 1. Okay, so in order to do that, the first thing I would do is I would call this a function. Okay, so I'd instead of it equals 0, I'd say like f of x, right? Or something, function f of x. In this case, of course, it's going to be f of function of t, isn't it? It's in terms of t. So t cubed minus 4t, or plus 4t minus 2. Okay, and what we'll do then is we'll chuck those values in. We'll put 0 in first of all, f of 0. Okay, so 0 cubed plus 4 times 0, take away 2. So you could use a calculator on that, or straight away you might see it's minus 2. Chuck 1 in there. Okay, so 1 cubed plus 4 times 1, take away 2. Again, you know, use your calculator, because this is a calculator paper, isn't it? And that comes out as 3. Now what's noticeable here, of course, is f of 0 comes out as minus 2. F of 1 comes out as 3. 1 is negative, 1 is positive. So if there's a change in sign, that means then the root alpha must lie between those two values. Okay, so we simply say change in sign, therefore root alpha exists between 0 and 1. Okay, you make that statement. It's important you make this statement. Once you've made that statement, you've shown there's a change in sign, and then therefore the result does exist between 0 and 1, and you've got the marks. Now, what they do next then is they give you this thing called a recurrence relation, okay? And this is just a rearrangement. This is technical, so rearrangement of this. You don't have to worry about it because they always give you this, right? They will always give you the recurrence relation. And they tell you t0 is 0.5, okay? And then it can be used to find alpha. So this recurrence relation can actually help you home in on the solution. So they tell you t0 is 0.5, and then it says find and record the values of t1, t2, t3, t4. Okay, so we want to find t1, t2, t3, t4. Now, what I want to show you, I'm going to show you like a long way of doing this, just to start with, and then I'll show you a quick way of doing it. If you think about it, t0 they've given this as 0.5. Okay, they told us. Now to get t1, if you think about it in here, right? If you wanted t1, then if you think about it, you'd have to set n to equal 0, wouldn't you? Yeah, because if you set n to equal 0, that would be 0 plus 1. And, you know, it's just 1, isn't it? But if n was 0, in the formula then, you'd get 2 minus t. Now, of course, n is 0, so it'd be t0 cubed over 4. What you're actually doing is using the previous result. Okay, so you type in 2, take away the previous result, the t0, which they give you. So you put that in there, and it will give you an answer. Okay, so I could work that out, couldn't I? 2 take away 0.5 cubed over 4, and it give me an answer, so 0.46875. Okay, that's your t1. Now they want t2, t3, and so on. To get t2, of course, if you think of the formula, I'd put in 2, take away, of course, t2, if you want that to be 2, n would have to be 1, wouldn't it? N would have to be 1. So then if n is 1, you'd have to take away t1 cubed over 4. Alright? So hopefully you can see what's going on here, because of course t1 is the answer you just had. So you'd be putting 0.46875 cubed in over 4 and so on. Does that make sense? Okay? And you get an answer for it. You know, I could work it out on my calculator. And then when it comes to t3, of course t3 would be using the t2 result. Okay, so you're always using the previous answer. The trouble with this is, right, is if you do it this way, it's going to take a long time, all right? Because these answers get quite long, all right? You have to type all this into your calculator. It becomes a bit of a pain, right? But there is a quick way of doing it, okay? And I'm going to show you as follows, right? You don't actually have to type all these numbers in like this. What you can do is this. We set t0 to equal 0.5, okay? Right? Now, on my calculator, right, what I'm going to do, I'm going to type in 0.5, I'm going to type in t0, and I'm going to press the equals button. If I press the equals button, my answer is now, my answer button here, is 0.5, won't it? Okay? And what I'll do then is, I'll set up the formula on the calculator, but for t1, instead of writing to take away 0.5 cubed over 4, instead of typing that in, I'm going to type in 2 take away ants cubed, okay, over 4. So if I do that, of course, the ants we know now is 0.5, and it'll give it to me. It'll give it to me as 0.46875, so I can write that down. Of course, when it comes to T2, the great thing is now I can use what I've got here, and if you think about it now, that ants is no longer 0.5. That ants is actually now my answer here, because it's overtaken by this answer, isn't it? Okay, so with my T2, of course, with my T2, I'm wanting to chuck that in, and I'm wanting to chuck in the T1 answer. Of course, my calculator knows that. It knows that answer now is this one. So if I press equals, again, I come up with 0.4742507935. Write it all down, right? It's important you write it all down, what your calculator says. And then we want T3. So T3, all I'm going to do is just press the equals button again. And it changes. Only slightly, but it does change. 0.47333361112. And then I'm going to do T4. So press the equals again. 0.473488027. It's so easy doing it that way. Once you've done that, it says write down the value of T4 correct to 4 decimal places. Okay, so T4 to 4 decimal places. So once you've written all these out, T4 then will be 0.4735, isn't it, to 4 decimal places? Okay, of course, because that's an 8 there, you round that up to a 5. So there's your answer there for T4. And we've done that. 4 decimal places. Then it says, prove that this value is the value of alpha correct to 4 decimal places. In other words, prove that actually alpha is equal to 0.4735. Show that this is the actual answer for alpha when it's rounded to 4 decimal places. So to actually prove that, what you do is, right, you just do a little number line work, okay, right, it takes a little bit of effort, but a little number line work, and you put the answer that we've got, 0.4735 here. Remember now it's 4 decimal places, so the next one in line would be 0.4736. You go the one above, but you also go the one below. Okay, so the one below would be 0.4734. Okay, so that's the answer I've got to 4 decimal places. The one below it, the one above it. What you do then is you go in the middle of those two. Okay, you go in the middle of those two to check what we've got here. So here would be 0.47355, okay, and the one between these two values would be 0.47345, okay. Now that we've got these, but we need to check these solutions in our original function, okay, just like before, to see if we're going to have a change in sign, okay. And if there's a change in sign, we can then be confident that this answer is correct to 4 decimal places. So if we go back to our original function, which is up here, okay, this is our original function. Don't use the iteration formula, forget that one. Use the original function and we'll chuck it in there, okay, we'll just chuck it in there. So we'll put in f of 0.47345, okay, so we'll chuck that one in. So in our original function, that will be, if I'm putting it in there, don't forget, that will be 0.47345 cubed plus 4 times 0.47345, take away 2, so if I work that out, have I done that correct? I think I have, haven't I? Oh well, right, take away 2. So it comes out as a negative, right? I know it's standard form, but it's negative, isn't it? Negative 7.38, should we say? Times, that's good enough, right? You don't have to put the exact thing down. That will do, right? That's the answer there. So it's negative. Now we hope in the next one will be positive. So 0.47355. So you need to write it all in, right? So what you're going to type into the calculator, you need to have written down here. Now the good thing is, with the calculator, you just go hit the replay button and you just change these numbers here, okay? Don't bother typing them in again, just change the 4 to a 5 in that case. And look, it comes out as positive. Okay, again in standard form, but look in front, it's just 3.93 times 10 to the minus 4. 10 to the minus 4 just means it's a really small number, so it'd be like 0.0003, I think, something like that. But it's positive. So what you say in the end, change in sign, therefore 0.4735 is correct to 4dp. Okay, brilliant. Job done. On to question 2.